Hello, we are going to present our work which concerns the DFT calculation of the nonlinear optical property of the molecule of 2,5-A 114070 hexaterbity hexapyria hexabenzochole and its derivative functional with a potassium atom influence of doping. In introduction, nowadays, the need for a better internet connection is more and more thin. This can be seen in the transmission of concrete from 3 giga, 4 giga to 5 giga. Nevertheless, connection problem has the nothing of a light skin. This may be due to the different materials that make up the optical fiber. See figure 1. The optical fiber is a waveguide that exploits the refractive properties of light. It allows the transmission of the optical signal from one point to another and gives way to the field of nonlinear optics. At some point, the optical signal can be altered during its propagation. As a result, it will be interesting to propose no material that will serve as signal amplifier. The material recommended for application in nonlinear optics are those with a good absorption spectrum in the visible range and a higher value of the first order hyperpolarizability. Organic matter have proven to be suitable for nonlinear optic application. Amongst the organic material, we have especially focused on the molecules 258, 114070 hexaterbity hexapyria hexabenzochole, abbreviated THBC, because it already shows a higher absorbance in the visible range. Moreover, it is a symmetrical molecule which limits its application in the nonlinear range. To enlarge the field of application of this molecule in the nonlinear domain, we propose to dope this molecule with a potassium atom. The purpose of our research is to extend the field of application of this molecule in the nonlinear domain. Our main objective is to improve the property of THBC cool doping with a potassium atom. We use density functional theory, cool ivory functional, the V3PW91 functional, which is a Baker quick parameter exchange functional with the PQ1 correlation functional, and the ISE IB functional, which is a short range IB functional used by Hayes with N0 associated with the 631 plus DGP basis set to carry out our research. As highway, we use Gauss view for the visualization geometry and Gaussian system to perform the calculation. As a result, we represent the histogram of the development and the first order hyperpolarizability. Figure A shows the value of the development of the system under study. It indicates the change distribution in a molecule and allows ancosymmetric molecule to be distinct from non-ancosymmetric molecule. The higher it is, the more unequal the change distribution in the considered molecule is. The THBC1 molecule is both method has the higher value of the dipole moment. This was quite predictable because the addition of a single potassium atom made this molecule non-ancosymmetric compared to THBC PSA, which is ancosymmetric. This allows us to say that the change in the molecule are inequitably distributed and is a favorable point to obtain a higher value of the first order hyperpolarizability. Figure B thus highlights the first order hyperpolarizability value of the study molecule. The beta value of the THBC1 molecule is larger than that of the base THBC molecule. In order to classify this molecule as nonlinear optics, this beta value was compared to the experimental calculation beta value of a molecule that served as a reference to qualify a suitable molecule for ONA application is paraniquanilin. The experimental beta value of paraniquanilin is given in the blue box. The beta value of the THBC molecule is also larger than the value of paraniquanilin. The presence of the potassium atom and the symmetric breaking allow the THBC1 molecule to be classified as suitable for ONL application. This confirms that nonlinear optic properties are closely related to geometrical shape and that molecules with large dipole moment value are predisposed to have large beta value. In conclusion, the presence of the potassium atom of the THBC-based molecule has influenced the value of the dipole moment and the first order hyperpolarizability. The high value of the first order hyperpolarizability of the proposed derived molecule allows us to classify this molecule as a potential candidate for application in nonlinear optics. Thank you for your kind attention.